Here we're going to change gears a bit. Instead of solving for a z, we're going to solve for a value x this time, given a z, mean, and population standard deviation. And what we'll do is we used to use the z-score formula, and now through algebraic manipulation, which I'm not going to go into here, but we could solve for x instead. And if we did that, this formula would be re-expressed as the following. X equals mu plus z times sigma. Okay, so if I ask you to solve for x, or if you need to solve for x in general, what you want to do is you want to use this formula right here. If I ask you to solve for z, or if you encounter a problem where you need to find z, then you want to use this formula here. All right, let's take a look at 3 examples in solving for x. All right, in our first example, suppose I gave you a z of 0.50 with a mean of 50 and a standard deviation of 10. And I asked you to solve for x. Okay, here, we're going to just plug it in. So I have x equals mu, which is 50, plus z, which is 0.5. And usually at this point, when I multiply z times sigma, I'll typically use parentheses. It just makes it easier to separate the values. And if you have a negative, it can come in handy, a negative z. Okay, so here we have 0.50 for our z-score. And then we have a sigma of 10. So this is equal to 50 plus 0.5 times 10 is 5. So 50 plus 5, or an x of 55. Okay, so a z of 0.5 with a mean of 50 and standard deviation of 10 gives me an x of 55. Let's take a look at another example. Here we have a negative z, a z of negative 1.25, a mean of 100, and a standard deviation of 20. Okay, here, using our formula again, x equals mu plus z times sigma, we have a mu of 100, right? Mu 100 plus a z of negative 1.25 times a sigma of 20. So this gives us 100 plus negative 1.25 times 20, which you could solve for in your calculator, is plus a negative 25, okay, which is equal to 100 minus 25 is 75. Okay, so a z of negative 1.25, a mu of 100, and a sigma of 20 gives us an x of 75. Okay, for our last example, let's take a z of 1.35, a mean of 50, and a standard deviation of 10. Once again, solving for x, we see x is equal to mean of 50 plus a z of 1.35 times a sigma of 10, or 50 plus 1.35 times 10 is 13.5, or an x of 63.5. So when we have a z of 1.35, a mean of 50, and a standard deviation of 10, that gives us an x of 63.5. Now before we wrap up with these examples, let's take a look at one thing here. I want to see if you can follow along with me on this concept to try and better understand and reinforce, really, our understanding of z-scores. Notice here that I had a z of 0.5. Do you recall that a z indicates the number of standard deviations a score is away from the mean? Well, this tells us that the score, whatever it may be, at this point we didn't know. We were going to solve for x here. That x is 1/2 of a standard deviation above the mean. And it's above the mean because the z is positive. So I actually could probably figure that out without using the formula in this case. If you think about it, if my x is 1/2 of the standard deviation above the mean, well, you ask yourself, how much is the standard deviation? It's 10 points. What is 1/2 of 10? That's 5 points. So this score is 5 points above the mean. Well, if the mean is 50, what is 5 points above that? 55. And that was our value. Okay, we could do that again here, although it's a little more complicated because the numbers aren't quite as clean and easy to do in our head. But if I have a score that's 1.25 standard deviations below the mean, okay, and my mean is 100, then I know it's going to be, let's round it to 1 for a minute just to make it simpler. Let's say it was 1 standard deviation below the mean. Well, if the standard deviation is 20 points, then it would be 1 of those below the mean, and it would be 80. 20 below 100 is 80. But in this case, it's 1.25 standard deviations below the mean, so it's actually 25 points below the mean, or 75. Once again, that one's a little more complicated because it's not a nice even number to work with. Okay, and this one would be the same result, as it's not a nice even number. But conceptually, you should understand this. If I asked you, let's say we had a mean of 50 and a standard deviation of 10, and I had a z-score of 1, positive 1. What is the x? You should tell yourself a z of 1 indicates that x is 1 standard deviation above the mean. If my mean is 50 and my standard deviation is 10, then it's one of these, or 10 points above the mean. If the mean is 50 and it's 10 points above that, then it should be 60, okay, if my z is 1. Now, all you really need to do is solve for z and solve for x and understand that a z-score indicates how many standard deviations a score is above or below the mean. But if you understand that concept, it will help you make better sense of these values. Okay, you can kind of check them to see if they seem reasonable or not. This concludes our demonstration of solving for an x given a z, mean, and sigma.